Ever been in a situation where a service failure in a microservice architecture left you scrambling for solutions? When you're dealing with complex applications that rely on the harmony of multiple microservices, one faulty service can be the domino that triggers a ripple effect of failures. It's like a string of Christmas lights. One faulty bulb can plunge the whole string into darkness. So, how do you manage such situations? Enter the circuit breaker pattern, a design pattern that can be your saving grace in these scenarios. This pattern, popularized by Michael Nygaard in his book Release It, works kind of like an electrical circuit breaker in your home. An electrical circuit breaker automatically interrupts the current when there is an abnormality in the circuit to prevent damage. Similarly, in the world of software, a circuit breaker pattern can interrupt or prevent a call or service from retrying a service call that has previously caused repeated timeouts or failures. Imagine this. You have a microservice that keeps calling another service, but it's not getting a response because the callee's service is down. If this continues, it can lead to network contention and database thread pool consumption, degrading the performance of the entire application. This is where the circuit breaker pattern comes into play. It's positioned between the caller and callee service, and it trips if the callee is unavailable, preventing repeated calls and potential system overload. But that's not all. This smart pattern can also detect when the faulty service is back up and running. It's like having a watchdog that not only prevents disasters but also keeps an eye on service recovery. In the realm of distributed computing, where network reliability, zero latency expectations, and bandwidth limitations are often taken for granted, the circuit breaker pattern can be a robust safety net. It can prevent your application from indefinitely waiting for a reply during a network outage and reduce the risk of application degradation. Understanding the circuit breaker pattern can be a game changer in managing service failures. With this pattern in your developer's toolkit, you can navigate the treacherous seas of service failures with a reliable lifeboat. You may wonder, why do we need the circuit breaker pattern? Well, let's dive into the motivation behind this ingenious pattern. Picture this: a complex application running on multiple microservices, each handling their respective tasks. It's a well-oiled machine until one of these services goes down or starts to lag. Suddenly, the entire application feels the strain. This is where the circuit breaker pattern steps in. In an ideal world, all our microservices would run smoothly without a hitch. But the reality is, services may become unavailable or exhibit high latency. When this happens, it can cause a domino effect of failures across the application. Imagine if you were to make a phone call, but the line is busy, or there's no answer. Would you keep calling non-stop, or would you wait and try again later? That's the premise behind the circuit breaker pattern. This pattern was popularized by Michael Nygaard in his book, Release It. It's like an electrical circuit breaker, which trips when there's a fault in the circuit to prevent further damage. Similarly, a circuit breaker in software development trips when a service call causes repeated timeouts or failures, preventing the calling service from retrying the call. This proactive approach can save valuable resources and prevent network contention and database thread pool consumption, which could otherwise degrade the performance of the entire application. But there's more to the circuit breaker pattern than just preventing retries. It can also detect when the troublesome service is back up and running again, thus ensuring that the application can resume normal operation as soon as possible. The fallacies of distributed computing, a set of assertions made by Peter Deutsch and others at Sun Microsystems, remind us that programmers often make false assumptions about network reliability, latency, and bandwidth. The circuit breaker pattern helps us tackle these challenges, ensuring our applications are resilient and can handle network errors effectively. The circuit breaker pattern, in essence, is a safeguard against cascading failures and poor user experience. It's a tool that allows us to build robust applications that can weather the storms of network issues and service failures. It's about being prepared, because in the world of software development, it's not a matter of if things will go wrong, but when. Now, let's delve into the mechanics of the circuit breaker pattern. Imagine an electrical circuit breaker, a device designed to interrupt the flow of current in an electrical circuit to protect other devices from damage. When an abnormality, such as a surge in current, is detected, The circuit breaker trips or shuts off the flow of current, thus preventing potential damage to the appliances connected to it. This is precisely how the circuit breaker pattern functions in the realm of software development. It serves as a protective intermediary between two interacting services, which we'll refer to as the caller and the Kali. The circuit breaker object is strategically situated between these two services, monitoring the communication between them. The circuit breaker object watches for any signs of trouble. For instance, if the Kali service becomes unavailable or starts exhibiting high latency, the circuit breaker detects this abnormality. Much like its electrical counterpart, it trips, effectively interrupting the flow of requests from the caller to the Kali. This action prevents the caller service from making unnecessary and potentially harmful retrieves, which can lead to network contention and a significant drain on resources. But the function of the circuit breaker pattern extends beyond just interrupting the flow of requests. It also plays a crucial role in detecting when the Kali service has recovered and is functioning normally again. Once the Kali service is back up and running, the circuit breaker resets itself, allowing the flow of requests to resume. This smart mechanism allows for better management of service calls, preventing redundant attempts that could exacerbate the problem and cause performance degradation throughout the entire application. It's important to remember that the circuit breaker pattern is not a panacea for all issues related to service calls. It is a tool, a protective measure designed to handle specific situations where service calls are likely to fail or cause timeouts due to issues with the Kali service. The circuit breaker pattern effectively manages service calls, preventing unnecessary retrieves and network contention. So when should you use the circuit breaker pattern? The circuit breaker pattern really comes into its own in a couple of key scenarios. Let's delve into these situations to understand when this pattern can be a lifesaver. First, consider a situation where the caller service is making a call that is most likely going to fail. Maybe the service it's trying to reach is down, or there's some other issue preventing the call from going through. The circuit breaker pattern can step in here, preventing the caller service from repeatedly attempting a call destined to fail, saving valuable resources and time. Next, think about when high latency exhibited by the Kali service causes timeouts. This could be due to slow database connections or other performance issues. When the Kali service is slow to respond, the caller service might be left hanging, waiting for a response that takes too long to arrive. This could lead to poor user experience, as it might cause the entire application to slow down or even crash. The circuit breaker pattern can mitigate this by detecting the high latency and breaking the call, preventing the caller service from getting stuck in a timeout loop. Finally, the circuit breaker pattern is also valuable when the Kali service isn't available or exhibits high latency. In a microservices architecture, services depend on each other to function properly. When one service is unavailable or slow, it can cause a cascade of issues across the whole application. By using the circuit breaker pattern, we can stop this cascade before it gets out of hand. If a service isn't available or is responding slowly, the circuit breaker will trip, preventing further calls and allowing the system to handle the issue gracefully. In conclusion, the circuit breaker pattern is an invaluable tool when dealing with service calls in these challenging conditions. It can prevent persistent call failures, handle high latency, and manage unavailable services effectively, helping to maintain the overall health and performance of your application. The circuit breaker pattern is a powerful tool for managing service calls under these challenging conditions. Before you rush to implement the circuit breaker pattern, there are a few considerations to keep in mind. The first is service-agnostic implementation. This is a fancy way of saying that the circuit breaker should be implemented in a way that is independent of the specific microservices involved. This prevents code bloat and ensures that the circuit breaker can be used across different services with ease. To achieve this, we recommend an API-driven approach. This means designing the circuit breaker as a separate service with its own API. This service can then be called by other microservices when they need to interact with a potentially unreliable service. The circuit breaker service will handle the logic of tracking failures, opening and closing the circuit, and providing an alternate response when the circuit is open. The second consideration is circuit closure by the Kali. Now, typically, the circuit breaker monitors the failures and decides when to open and close the circuit. But what if the Kali service, the one that had been failing, recovers from the issue and is now fully operational? Should it just wait for the circuit breaker to realize this and close the circuit? Not necessarily. An extension of the circuit breaker pattern allows the Kali service to update the circuit status to closed once it recovers from the failure. This proactive approach can minimize the downtime and improve the overall user experience. However, it does require the Kali service to be aware of the circuit breaker and to have the ability to interact with it. These considerations may add a layer of complexity to the implementation of the circuit breaker pattern, but they can make a significant difference in how effectively the pattern works in a real-world scenario. They can help prevent unnecessary retries, reduce network contention, and ensure that services recover quickly after failures. With these considerations in mind, you're well equipped to implement the circuit breaker pattern effectively in your microservices.